What's the first thing most people do when they start making breakfast? In many households across the US, we put on a pot of coffee or fire up the Keurig. According to the National Coffee Association, Americans drink nearly 587 million cups of coffee every day. And with 70 beans per cup, that's a lot of coffee beans. But what many people don't know is that only 6% of the original coffee bean actually reaches your cup of coffee. Most of the beans, after roasting, grinding, and brewing, are discarded into dumpsters or landfills, generating harmful greenhouse gases and creating thousands of pounds of coffee waste. But what exactly does coffee waste look like? This is a coffee bean. Coffee starts as a green bean and then is put into a roaster where heat is applied until the bean reaches the appropriate temperature and color. What results is, of course, the brown coffee bean we all know and love, but also a papery skin that falls from the bean during the roasting process called chaff. This chaff is often bagged and thrown away, generating our first major form of coffee waste. The brown bean itself is then shipped, ground, and brewed into your favorite cup of joe. After brewing, the wet grounds, often referred to as spent coffee grounds or SCG, are thrown away, creating our second major form of coffee waste. That's where our team comes in. Our goal is to help divert coffee waste away from landfills and towards a process that valorizes them. One way we're doing that is by supporting the production of coffee biochar right here at RIT. What exactly is biochar? Biochar is a charcoal-like product made by burning organic materials at high temperature with very little oxygen. This process is called pyrolysis. Biochar can be made from almost any organic material, and different types are used in many different applications. Depending on the pH, moisture content, and chemical makeup of the biochar, it can be useful in agricultural practices, cements and structural applications, 3D printing materials or other plastics, and so much more. In our project specifically, we're combining chaff and SCG to create different biochar samples and determining which applications coffee biochar would be best suited for. Our team is also looking into logistics. How can we get all of this SCG and chaff to a refinery to actually make biochar in the real world? We're using a simulation software called Simeo to map out this process. Using data from different coffee roasters and distributors, the model can quickly run a real-time situation to help predict costs, times, and performance without actually having to build the system in real life. Using the model results as a guide, we can help coffee producers understand how to best divert their coffee waste and to explore new ways for making a more positive impact on the environment. So, next time you order your favorite cup of coffee, don't forget how far those coffee beans go and how much the future may hold for them.